This is a practice problem where I show you how to calculate the average atomic mass of an element. Spoiler alert, the correct answers for these types of problems are on the periodic table, but your teacher or professor can still write the problem in such a way that they make you prove that you know how to calculate it. I'll talk about that a little bit later. Let's take a look at magnesium. Its atomic number is 12 because each and every magnesium atom has 12 protons in the nucleus. The average atomic mass is 24.305 atomic mass units. I'm going to show you how that average atomic mass was calculated. Here's the text of our problem. A sample of magnesium is found to contain 78.70% magnesium-24 atoms, each with a mass of 23.98 AMU, 10.13% magnesium-25 atoms, each with a mass of 24.99 AMU, and 11.17% of magnesium-26 atoms, each with a mass of 25.98 AMU. Calculate the average mass of a magnesium ion. So we have 3 isotopes, each with a different mass, and we're calculating the average. But this is not just as simple as taking the average of those 3 numbers. We need to take a weighted average that takes into account the fact that the abundances of these isotopes are not all the same. So there are 3 steps that we need to perform to do this calculation. The first step is that we need to take those percent abundances and divide each of them by 100 to turn them into decimals representing the abundances. By the way, these 3 decimals should have a sum of 1 because we need to account for 100% of the sample. In our second step, we need to multiply each of these decimal abundances by the associated mass. Let's evaluate these. And our third step is to find the sum of all of these values. Let's talk about significant figures in a minute, but right now I want to talk about what I can do as a professor to make sure that you actually knew how to calculate this answer. The problem is that this answer is on the periodic table, and I would like to give students access to a periodic table. So the first thing I can do is just make up a fictitious element. At the time of recording, there are 118 elements on the periodic table. I can just make up fictitious element number 120, make up abundances and masses, and a student would have to go through these 3 steps of the calculation. To make it a little bit fun, I could even take a page out of Glenn Seaborg's book and name this fictitious element after myself, my lab, or my school. The second thing I can do is be really uptight about significant figures. So the answer to this problem, we have not evaluated significant figures yet, but it actually has a different number of significant figures than the periodic table I would provide. So let's look at the significant figures of this problem. So there are different rules for different mathematical operations, but our rule for multiplication and division is that you look at how many digits are in the original numbers, and whichever of these is the fewest is how many are in the answer. So here we have 4 significant figures, 1, 2, 3, 4. Here we also have 4 significant figures, 1, 2, 3, 4. Those are the same value, but the lesser of 4 and 4 is 4. This answer has 4 significant figures, so we know 18.87. We need to do that same process for these next 2 multiplication steps. 4 significant figures and 4 significant figures. This value, we know 4 significant figures, 2.531. Same here. 4 significant figures and 4 significant figures. We know 4 significant figures here. The addition and subtraction rules are different. So for this value, we need to consider how many digits we know after the decimal place for each of these. Here we know 2 digits after the decimal place. Here we know 3. Here we know 3. We only know 2 digits after the decimal place in all of these numbers. If we start looking at this 3rd digit, we don't know this 2 with certainty. We only had 4 significant figures here. This 2 would be the 5th digit. So we only know 2 digits after the decimal in all of these. So think of that as our cutoff. We only know 2 digits after the decimal. That means we only know the 24.30. This 5 causes it to round up. So our answer is 24.31 atomic mass units. And again, if your teacher or professor is really a stickler for significant figures, this is something that they could do to make sure you actually calculated this problem. This answer is 24.31 atomic mass units, but the periodic table I was showing you shows that magnesium has an average atomic mass of 24.305 atomic mass units.